Okay, this is Avogadro's hypothesis. This is the same guy who gave us Avogadro's number. Okay, so Avogadro is kind of the mole guy. And what he said was, equal volumes of gases at the same temperature and pressure contain equal number of particles. And if you are at standard temperature and pressure, 1 mole is always 22.4 liters, no matter what it is. So he's still, even with gases, the mole guy. So this is just another ratio that we're going to use to convert. Okay, so what is the volume? So liters is what we're looking for, and we're given 0.25 moles. So we have moles in the bottom, liters in the top. Liters is 22.4, moles is 1. So we have 0.25 times 22.4. And we get 5.6. And on this one, it just doesn't tell the formula of the gas, because it doesn't matter. Now look at the next one. What is the mass? So we want grams, given 10 liters. This time you need the formula, and you know that it's O2. Liters on the bottom, moles on the top. Moles is 1, liters is 22.4. Now we need grams. We're not at grams yet, so we're going to need another fraction. So what we need in the bottom of that fraction is moles, so that it cancels. Grams in the top, because grams is what we're looking for. Moles and grams is where we use the molar mass, which remember was add up from periodic table. So oxygen is 32.00 and moles is 1. So we have 10 times 1 divided by 22.4 times 32 divided by 1. And we get 14.3. Okay, so try the practice problem. How many grams? So grams is what we're looking for. Given 2 liters of N2. So of course it's grams of N2 we're looking for. So liters of N2 is coming to the bottom. Moles of N2 at the top. 1 goes with moles, 22.4 goes with liters. So now we bring moles to the bottom and grams to the top. Grams we get from the periodic table, and moles is 1. So we have 2 times 1 divided by 22.4 times 28.02 divided by 1. And we get 2.50. Now Avogadro also has a gas law. which is also part of the ideal gas law. This gas law basically says put more air in a balloon, it gets bigger. You gotta love the gas laws. They make sense. Now, what you have to watch out for. Whoa, you gotta watch out for the screen scrolling on you uncontrollably, apparently. Okay. Watch out for. You are usually not given N1 and N2. You're given N1 and then told gas leaks or gas is added. So let's look at this one. 2 moles, so there's N1. Has a volume of 22.0 liters. So there's V1. What is the volume? So V2 is the unknown. After 32.0 grams of oxygen are added. So that means N2 is 2 moles plus something. So 32 grams of oxygen. How many moles is So how many moles of oxygen? Well, 1 mole of oxygen, grams of oxygen on the bottom from the periodic table, and, oh, it is 32, so we're adding 1 mole. So therefore N2 is 3 moles. Switch color here because I'm kind of out of space. Alright, so V1 over N1 equals V2 over N2. Solving for V2, so we're going to multiply both sides by N2. So we have 3 moles times 22 liters divided by 2 moles. Moles cancel. V2 is 33 liters. Okay, so there's a practice one for you to try. Now, we have 1.50 moles, so there's our N1. And it has a volume of 8 liters. What is the new volume? So V2 is our unknown. If a leak allows 1/2 of the neon to escape, so if we lose half of it, we now have 0.75 moles. Okay? Now, just think of some logic here. If you have half the gas, and volume and moles are directly related, you're going to have half the volume. And if we do the numbers, it's going to give us the same answer.